Hey everyone, Cem Tezcan here. Today we continue our speedrun process with Solidworks and we are creating this handheld console, and today we are adding more details to this 3D model. And after this point we are going to create the UVs for the object, and then we will be creating textures for this piece, and then we are going to render it, of course. So let's continue 3D modeling this. At the last part, we get this model up to this stage, and let's see what we can do about giving additional details to it. So for example, our battery hatch is still missing, and we will be adding some ports or connectors here and there to make it much more effective as a handheld console, because this kind of devices back in 90s has video outputs and has some ports to use additional controllers with them, and also volume buttons or charge connectors, etc. will be placed around this piece. So let's move on by that. Last time we added the buttons, and we have this grip indents at the back, and also we have completed the screen, which looks not bad if you ask me. But let's add some fillet to these corners, because nothing is perfectly rectangular on plastic creation. Remove, because I may be editing some existing feature. So let's add a new fillet. One millimeter radius works nice. Alright, we can also add some chamfer to the outer frame, with a tiny amount, of course. Yeah. Alright, we can show all the bodies and check the 3D model. Alright, so let's make the battery hatch, because that is one of the characteristic shapes on this kind of devices. Let me check the AA battery size. Right, it's various, but this dimensions gives an idea. Let me reflect it as a rectangle. So 50 millimeters works nice, and 40 millimeters is also cool. So we are creating this shape for just determining how much space we need for this hatch. And let's make this linearly tiled. All right, Let's make it works with 4 batteries. Alright, so this is the reference battery drawings actually. So let me center those to the 3D model layout. I'm going to switch to the feature tab. Yeah. Right. By the way, sorry for the sound quality of the previous chapter. I think I'm going to fix it this time. And also, recording these videos in 4K resolution with 60 FPS is a kind of system, so it's kind of depletes system sources. So let me pause this video here and switch to the 30 frames at second. Alright, this time we switch to the 30 FPS. You won't be recognizing the difference because I will be just rendering this final video as 30 FPS. Alright, and this is the possible battery placement, and let me fix these batteries here. And now I'm going to add some clearance distances around the batteries. For example, 4mm works nice from each side, and for the top I will be adding more distance because we will be using a hook to keep the battery hatch closed, so maybe 10mm distance will work fine. Alright, so we have a rectangle here, and I am going to create an extruded cut here with a thin feature, of course. I will make it around, let's start by making it 1mm thickness, and I will cut extrude it around 1mm. Alright, now it's create a kind of hatch. By the way, we can use some fillet around this rectangle as well. Right. And one other thing I need to do is creating this thin feature in the middle of the line, so it will be symmetrically through the shape I draw. Also, we can change the thickness. Let's make it 2mm. Nice. Now I'm going to use the same sketch to make another extrude cut here. This time I will be making the distance as 4mm, and I will be using thin feature again. But this time I will be setting the thickness as 0.2mm. Alright. We can change the distance. Let's make it 1 millimeter and use this surface as a starting area. 1 millimeter is still too depth. Alright, so 1 millimeter works. 0.5 millimeter depth works great. So we are having this hatch like this. My next step will be adding another house for the hook of this hatch. So let's set it as 15 millimeters and 8 millimeters works nice. Let's center this like here. And I'm going to cut extrude this around 5 millimeters and see what happens. Alright, we are going to extend the shape around here. So let me see. Right. I will connect this to here. Nice. And now I'm going to create another sketch for the hatch hook. Actually, we are creating a hook for this battery compartment hatch in a way of looking like a cosmetic view, not operational. So this will be just look like a hook. We are not functionally defining or separating the meshes through the main body, from the main body. So let's define some distances here. Point 0.5 works nice. And now I am extruding this by using offset from surface around 0.2 like this. Let me not merge this one right now. And by this surface I'm creating another sketch, which will be more or less like a hook of this part. Dimensioning got wrong. Alright. So let's make these as 0.5. 2 millimeter works nice. 0.4 works nice. 1.5. 1 millimeter. Nice. And now I am extruding this up to this point, but this time I will merge with the first extruded part. Alright, let's use a section view by selecting this face, which is here, and I am going to define another sketch to cut through this shape. So it will be more or less like this. Let's extrude this like that. Right. And also we can edit the sketch to make one last touch to it. Alright, now we can commit this change and create this shape like this. Let's make some more touches to this part. I'm defining some dimensions here and there. Okay. I'm creating an indent to use fingers to pull this part. Let's fully define this shape. So if we edit this hatch, it won't cause us any problem. It's not looking nice by this shape look, if you ask me. So let's change the sizes a little bit. Looks better. Alright, now I'm adding additional fillets here. Software is kind of slow today. I'm not sure why it's like that. So I am smoothing this all the way. But you will see that we haven't merged it with the back part. So let's make one final sketch to merge it with the rest of the hatch. All right. Now we are having a nice look for a battery hatch on this. So we can continue filleting the overall hatch as well. Yes. So I was not foreseeing that we are going to put the hatch to keep or consume all the area at the back part. So I was planning to put some labels here somewhere, but this hatch just takes so much space for the back part. So let's try to make it evenly placed at the backstage, at the back surface. So I will be using the label at the bottom part. So let me change the sketch for defining this hatch like this. And I am trying to see where we just fixed the positioning of this hatch sketch. So I assume that we have fixed some of the lines of this battery sketches. So let me see the relations first. I'm looking for a fixed, yeah. We have fixed this point here. I'm deleting this relation, so I will be able to move this to the top. So non-destructive workflow wins another round. Let's see if it will work. Actually, we got some trouble because of some of the shapes that we haven't defined correctly. And this will be the drawing we need to fix, because we haven't just defined a dimension here. So let me define it like that. And after giving OK to that, our hatch will be moved in a nice way. For example, you will see that we have this sketch right here. If I make it visible, we will be able to see the lines for this battery hatch, and it will be possible for us to move all the steps to create this hatch. For example, if I move this batteries all the way down, the hatch will be formed right here. So it will be easier for me to just create a nice look on adjusting the position of this hatch. But better than that is to position this hatch rectangle in a perfectly middle way of this grip indents. So I will be connecting this line to the middle point of the edges of this indents, and I will be making these setting these as horizontal and setting this as for construction. Now hatch will be created like this. I'm not sure about the overall layout. Let's edit this one last time. I see that positioning it manually was the better idea. So let's delete this line. And make the positioning including seeing the hatch hook like this. Now it looks better on overall layout of this battery compartment. And checking to see if we are having or forgetting anything. Alright, looks nice. So we will be adding some lights somewhere. Possibly this surface is a good idea, because you see that this kind of devices has some indicator lights that shows if they are operating or disk accessing kind of activities. So let's add 2 diagonal edge LEDs here. Actually, these will be the diffusers of the LEDs that placed inside the shell, but they will work fine, I suppose. Let me see some dimensioning here. Let's start by setting this as a 45 degrees. And define a thickness. What about 2 millimeters? Checking some reference measure in front of me. And let's set this point. Actually, it's hard to set a point by here. Instead of that, I will define another line like this. Let's connect it to this edge. And now I will be able to define a distance for this line. Let's make it 4.5 millimeters. All right. I am copying and pasting the same shape. Let me see if it can be broken. Yes, sadly it is. We need to define some relations, setting them collinear and equal. And of course, we will be setting a distance between these two. 5 millimeter works fine. Alright, now we are using cut extrude for these shapes. Let's make it 3, even 4 millimeters. But the way we need is actually not deleting them. So we can use a thin feature for this purpose. Or even better, we can extrude these as surfaces. Let me show you what I have in my mind. I'm setting this as 4 millimeters. Right. So I will add a plane here. For that plane, I'm going to create a sketch and convert the previous rectangles like this, and set those as planar surfaces as well. Clicking OK. Now I'm going to knit these surfaces. These are not touching each other, so I need to knit them separately. Very nice. Now I will go for splitting the mesh, the main body, with these surfaces. So I'm setting these as trim tools, and setting this body to cut. One of them is not slicing the shape. It's very strange. Let me check it first. Because of the angular shape, I suppose. So to fix that, I'm going to change the extrusion system of this 4 millimeter surface in a mid plane. And I double the distance. Let's try splitting once again. We need to end with 3 bodies, but instead we have 1. Let me check the surface bodies. Yes, this explains that we are not having a right shape. Let me see if the surface touches. Actually, there's no problem with that. Yes, we defined the knitting in a wrong way. Now one last time we are going to try to split this body, and we end up with 3 bodies this time. I'm selecting all of them, deselecting consume cut bodies, so I will be having 3 separate bodies. I'm going to delete these surfaces. Alright. Now the tricky part about these shapes, I'm going to use the same sketch for cut extrude a seam through this intersection of these 3 bodies. As a thin feature, I'm going to define 0.05. set the distance to 10 millimeters. Alright. Now you see that we will be having this seams through these LEDs. Actually, these are the diffusers. I'm going to change the thin feature to 0.2 millimeters. Much better. And now from direct editing, I'm going to move these upwards about the same distance. Alright. Now these are the diffusers. Since we have created the general shape, we can now adjust the dimensions back and forth. For example, in the sketches, let me see the correct sketch. Yes. We can increase the thickness of these rectangles. Alright, now let's define different material IDs for these two shapes. These will be LED diffusers. Nice. And here, this area, I'm planning to add a model name or a modeling or a label for expressing the name or brand of the device. But seeing this area, it looks also nice to create a label pole. Let's try it. Not a slot actually. Let's make a rectangle with rounded corners. I will draw a line in the middle of the rectangle edges. Now center this rectangle to this line. Alright. Let's make some clearance here. About 1.5 millimeters. And 2 millimeters by here. Alright, now I'm going to use a cut extrude. 0.2 millimeters will work fine. And let's use a fillet here. Nice. We will be having the brand right here. And also we will be adding some texture touches, like a painting over the plastic at this area, or for the buttons, and also start and select texts here and there. It will be nice to add this kind of texture details. Let's hide this plane. So now we are going for the label. Let's add a simple rectangle. I will be trying to make a good positioning. Actually, why not use an asymmetric shape like this? Nice. Let's cut this region, even this one, about 0.2 millimeters. And here I will define a custom fillet. Right. By selecting all the vertical edges, 2 millimeter roundness looks nice. And also we can add another label area here, like putting a serial number like this. Let's define that region for this cut extrude 2. Great. I'm adding another fillet for the corners of this new label area. 1 millimeter. Works nice. Good. And this will be the 2 labels we are going to add for this area. And we will be adding the brand right here. And next we are going for the other details. So since we are holding this console with 2 hands from left and right sides, and we have just used all the area at the bottom, only top part should be enough for us to add the connection ports that we are going to create for this device. So let's save the file and create a sketch for a placement of the desired connectors. Let me see the front part at the bottom. All right. So now we will be having a circle for AV port, audio video connector, which will be an S-video input, which should be around 10 millimeters. And let's check to see what to put. We can use a 6 millimeter AC connector to use the console with an adapter. And of course we can use a D-sub for using for attaching an external controller. All right. we will be having a volume wheel. Let's define it as 3 millimeters to 14 millimeters. Of course, we need to have a headphones jack. Let's make it 5 millimeter hole. What am I missing? Of course, we should be having an on and off button. Let's make it with a slot. So let's change the diameter to 5 millimeters. Right. This should be the on and off button here. Let's use the controller connector at the center. This was the charging or the AC input. Let's put it here. We have a 10 millimeter audio video input. Let's place it here. Right. I'm going to center this controller connector. Alright, headphone jack should be around the volume slider, so let's put these here by centering them to each other vertically. And this is the charging port. Yeah, let's actually, these connectors should not be intercepting each other because the cables should have enough clearances when they all connected, attached with a cable. Right. It's freezed right now. Yeah. So as I see it, my camera is not working, I suppose. Right. Alright, it seems like my video has been freezed somehow, but I'm stop that recording and starting a new one. I hope it's working normal right now. Alright, now we have placed some of the connectors here and there, and from the perspective view I can see that we will be having a nice layout at the top, and actually we can add another label here to show which button just works for which purpose. So Let's make this part as 22 millimeters to, let's say, 10 millimeters. I know it's not the correct D-sub connector size, but since we are having a speedrun here, let's keep it in an imaginary way. So we don't need to just confirm every dimension of any connector. So only thing that bothers me is that power up button. I didn't like the overall look. But if I set this parallel with that one, it will be look much better, I suppose. Yes, looking really good like this. Adjusting some of the dimensions. I'm adding some relations to keep a good positioning with these ports, because we just spread all of them here and there. So they need to be having some reasonable design purpose on the creation. All right. So let's move this here. Let's cut extrude these with 1 millimeter. Nice. Now we are having our layout. And now I'm adding another sketch to create a label area. This should be horizontal. This should be parallel with that one. This should be parallel with that one. Nice. Let's make some distance with that button. 3 millimeters should work Nice. All right. Let's keep the same distance for other shapes. I'm not sure about this speaker part. Let's see the distance of this part. 17.70. Let's keep it all the way. Alright, it's looking like a very random layout for a label, but I'm sure after some fillet it may look better. Fillet always helps on creating an illusion to fix the sharp edges and the artificial look on the design. Alright, so for that area I'm going to create some plastic style labeling here with a grainy look, so it will be showing the purposes of these buttons, which will look good, I suppose. And just let me edit the sketch once again by fixing some distances. Much better. So this way I just removed all the relations between this label sketch and the ports. So that way I will be able to change the order of the features. Before doing that, always save your file. So now I can edit this sketch with the label is created before creating this sketch. So, which is nice because now I can be able to position my objects according to that label. Yes, very nice. So let's set this. Actually, it's easy to center this by setting these two lines in an equal length. Great. Now the ports and the top label looks nice. And we have our hatch. We have the LEDs. Great. Now only thing we need to do is to add the details for the ports, because they have some female pins or the some connectors that the jacks put into there, and the volume wheel slider will be having some grips for to just adjust the volume, you know. So we will be adding these details. And by the way, let me change this position in a better way. All right, looks nice so far. Let's continue modeling the connection ports. So first I'm going to create the power button, power switch. It will be an easy task. So let's create a sketch here first. By here I'm going to create an offset for the sketch. And cut extrude it a little bit more. Right. And from the top part I'm going to create another sketch. Create another offset here. Let's make it 1 millimeter this time. But I am deleting the relation between this edge. Actually, not deleting. I'm going to just cut this from here. I will trim this area, convert this to construction line, and mirror it through here to make this button a little bit tinier than the rest. Also, I need to change my, let's see, the camera aspect ratio, I suppose. Fix it quick. Alright, this looks much better. We can zoom in a little. Yeah. Try to fix the exposure. Nice. And moving on by creating this switch, let's define a width for this button size, and now we can extrude this upwards. I'm not merging it right now because I need to add some more details on it. Let's extrude it more. I'm merging with the previous body. Nice. Let's make a fillet. I am adding another fillet. Nice. And I will add another sketch. This time I will use it for cutting this shape. So let's make it parallel with that one. Let's connect it to the middle. And I'm using an extruded cut with thin feature. Alright, this way we need to, we can slide it by nail. So let's use another fillet here and there. The tiny amount, of course. First we need to fillet the inner side. And then the rest. Great. Looks nice. So I'm not merging this button because we may need to move it on creating some animation in future. So let's only just add another fillet to the outer area like this. Great. Saving and moving on. For the S-video output, I need to check some image searching to see how it looks. It's pretty much like that. So let's keep it here. And I will try to make the look similar to that one. I'm creating another sketch here. I will convert this interior area. Since we need some depth, I am using cut extrude 4 mm inside. Alright. Another sketch. 0.1 mm offset. Extruded it upwards with a thin feature. I'm not merging it yet. Use some fillet to round the edges of this shape. Nice. And I will create another sketch. First I need to cut the outer bracelet we are seeing here. Let's make it 3 mm. All right. I'm only selecting the outer bracelet. Great. Let's offset the shape. Looks nice. I will be using a corner rectangle, actual standard rectangle, and now I am adding another corner rectangle. Great. Need a line to mirror the left rectangle. Right. I need one center rectangle. I'm mispronouncing center rectangle with corner rectangle for a while. Just realized that. Sorry for that, actually. Right, one pin and another one to here. Let's connect this to here. Let's make these two circles equal. Let's give them a diameter. Alright, that's it. So I am going to extrude this like that, about 5 millimeters, without merging the result. Nice, only problem is this rectangle. I will make it smaller. Much better. Alright, let's use a chamfer on... Actually, I'm seeing that my video just froze once again. Alright, now it's fixed. So let's use a chamfer here. Great. So this is our S-Video port. I will set the holes tinier. Alright. So this is pretty much it is. So next step is the AC input. Actually, it will be easy. First, convert the shape, cut extrude. Let's make it together with the headphones jack. I will convert this face to sketch as well. Now let's extrude cut those about 10 millimeters this time. Inside we will be needing an offsetted shape to be extruded. intent feature 0.5. Like this. Let's not merge it. I'm using fillet on the shape. Nice. Let me check the inner diameter of this port. It's 3.8 millimeters. So the headphones jacks are 3.5. So it will work nice with that threshold. And of course we will be needing another shape for the connectors inside, because for the battery, for the AC input, we need to have a pin here. So I'm creating a circle. Let's make it concentric with the inner surface. Right. .5 millimeter diameter works nice. Let's extrude it. I'm not merging this as well. And we'll be using a fillet with the same radius. Nice. I may change the radius of this shape a little bit. Let's make it 5 millimeters. And also the extrusion distance may change as well. Nice. I want to change the diameter of this to 1.2 millimeters. Of course, this means we need to change the fillet radius as well to 0.6, the half of it. Great. It's nearly looks same diameter with the headphone jack, but it doesn't matter because there are this kind of AC inputs, so it won't be a problem. Alright, now I will be going for the volume wheel. Let's see a section view. I'm using this. Actually, we can create a plane here at the middle of these two faces and use a section view by there. And by this plane selected, I'm going for creating the wheel. Alright. So let's create a circle. Perimeter circle works better on defining this kind of circles. This is the tangency, I suppose. Let's set it to outside. I don't like to define this kind of circles, so let's start by traditional circle and add some point on it to define better. For example, this will be centered on this edge. All right. And I will add 2 points and connect these points to these edges. Actually, this is the plane. Let's hide it. We don't need it anymore. It's coincident. This is as well. Alright, now I can adjust the size of this circle according to the slider. So you see that this kind of diameter works nice, considering the part that exceeds from the outer surface of our plastic. So let's make it 21 millimeter. Right. And now I'm going to exit this sketch first. And create an extruded shape in the mid plane. Let's make it, I'm not merging, by the way. 3 millimeters works nice. And also we can increase the diameter . 1 millimeter more. Alright, now I'm selecting the planar surface here, creating a sketch, converting it, and cut, extrude it about 5 millimeters, and selecting only our product. So this is the slider, how slider going to look. And one more addition to that, I'm creating another sketch at the bottom, offsetting it about 2 millimeters, and creating another extruded cut, but I will be setting it as offset from surface about 2 millimeters. But I forgot to select the body. Yeah, only this body will be affected by that. Alright, one thing that bothers me here are these edges, so I will go for a chamfer to see how it works. Okay. You can see the thing I did here was to remove the clearance with this wheel. So my next step is the grid marks over this shape. So let's create a sketch for it. I will create a line. And I will extend it here. So this both will be used. Let's make them equal and set this as 0.2. Nice. Now I'm going to cut extrude this in a thin feature selected. Let's define the thickness as 0.2 or 0.4, 0.25, 0.4 looks better, I suppose. And we need to set the distance of this cut extrusion as, let's say, 5 millimeters. Now I'm going to pattern this in a circular way. So for the circle, I'm selecting the outer arc of the volume wheel and set the tiling in a high number as 64. And by the way, I'm going to select this body to be affected. Nice. This is the volume slider, volume wheel, like this. But before that, I need to roll back here. But actually, I need to divide this cut extrude with the sketch and the cut operation by setting my history as between this cut and sketch. So I have this sketch, it's hidden right now. What I mean is this sketch, this line I draw here. Since after drawing that, I'm going to use a chamfer first before cutting that line. And for the chamfer, let's define it as 0.4 millimeters. Great. And now we can move on by subtracting or cutting the shape. Now our circular pattern doesn't work because it has no direction. Let's select another edge and complete the operation. Alright. Let's create a sketch. Offset this about 1 millimeter inside. Make an extruded cut about 0.2 millimeters here. So by selecting this feature and the plane between these two edges, I will use mirror. For the feature, I will set this. For the mirror plane, plane 2 is set. Selected bodies are these. And one last chamfer. You run here. I'm selecting wrong edges. Nice. All right. Now we have a nice volume wheel here. Rest of the parts. The only thing remained is the D-sub connector for the additional controller for playing two-player games, I suppose. But it will be still hard for anyone to play with these buttons as player 1 and other player to be used this port with a controller, but they will be trying to look to the same screen, which will be a little bit awkward, but I'm sure there are consoles that manufactured with that purpose. So it's kinda tradition, I suppose. Alright, let's go for the D-sub. I am creating a sketch. And I will define the form by my hand without a reference, but it doesn't matter so much since it's an imaginary device not going to be manufactured. Right. And let's use some fillets. Nice. Let's define some dimensions for this shape, because we will revise the outer shape. I need to make it narrower because we have defined a large rectangle for the outer part. Right. So. Right. Let's delete this and define it with this edge. Define it as 0.5. Right. Now it's wider, but I will change the rectangle shape to control it better. Let's save it first, because we may crash. You never know when your software going to crash, especially considering the Solidworks. We are doing some uncontrolled modeling. This means it may cause software to crash because it's not simple tasks on creating this kind of effects or modeling, because we are not creating something for manufacturing. This means software is not made for this kind of extraordinary modeling approaches. And we need to take this line up a little bit to the bottom, but yeah, I found the dimension that controls it. Let's move it here. Very good. Yes, everything gets back to normal. And now I'm going to create another sketch. this and set this and this by parallel like this. Great. Let's convert this one as well and extrude these two. But we need to change the extrusion distance to this point. By the way, this port line got very close to this edge because we defined this as 0.5. Let's make it 1 millimeter. So it will be having much more nicer clearance, which is like that. So let's add a fillet around this frame. Let's make it 1 millimeter. Great. Now I can use the sketch I created by cut extrude it. Actually not that one. I'm going to use the outer one, convert it and cut it through about 6 millimeters. Now we can use this sketch to extrude it. It will start from the back part. We'll extrude about 7 millimeters. Will be a thin feature, which is nice looking right now. Let's make it 7.5. Don't merge it. Let's use another fillet for the edge. .15. I need to adjust the thickness about 1 millimeter. And let's make it not touching to the edges because we can use two directions. 0.4 to the outer part, 0.5 to the inner part. Great. Changing the fillet radius. Also good. Now we are going for the pins. I'm creating a sketch. Still the proportion is not good enough. I'm going to adjust it more. But let's move on by creating the pins. For that, I will create a non-destructive relation. So even we change the shape of this port, the pins will not be affected. Alright, so let's set these as parallel. I will create the circles here and here. These will be equal and the diameter will be around 1.2 millimeters. Great. So let's define a distance for these two horizontal lines. Let's keep it that way. Software today is really slow. I'm not sure why. Maybe the recording causes it, because normally I don't remember using this slow. Alright, now let's make those as construction lines and use a linear sketch pattern with 6 instances. We will be using, actually not 6, 7, we will be using 5 of them. So I'm defining 2 more. Because I will eliminate the first and the last. And for the bottom, we will be having 4 pins. This means we need 6. And connect it here. So fully defined. Now let's set the first and last like this. So this way I'm going to extrude those like this. Let's merge it this time, because I don't want to use fillets on each of them. Right, I can't select all of the tips automatically, but it doesn't matter, just there is 9 of them. Good, let me check if it looks like a port. Let's search for D-sub connectors, 9 pins, male. Nice. I'm trying to save the image. Yes. This is what we are trying to get. It's not looking close right now, but sooner we will get the same look. Alright, let's change the height. Let me try to find. Yes. Alright, now it's looking something acceptable. And we have all the ports nicely defined. Really cool, actually. Looking forward to the object to see if it can end up with a nice handheld console. The answer is looking like a yes. Alright, so I am going to cut this chapter at this point. On the next stage, I'm going to show you defining all the material IDs. Actually, it's an easy task. We will just define the metallic parts or the plastics with the different colors, which will be hard for us to select in the polygon mode. So we will just define the different material IDs in Solidworks because, for example, you have a complicated shape here, but Solidworks can easily select those because there are no polygon type of selection system in the Solidworks. So it will be easier for us to define the material IDs in Solidworks, and by moving the 3D model into Modo, it will be easier for us to assign the UVs and the material IDs together or separately. So after that, we are going to export them into Substance Painter, create the textures for it, and get it back to render this time. I'm not decided how to render this piece because Marmoset Toolbag 4 is great on rendering this kind of speedy product animations or product renderings, and also Octane Render works great with photorealistic results. So we will decide it at that stage after we create the textures. So we have about 2 hours of work, I suppose, for the UVs and the texturing. So the rendering will not be taking us so much time because it will be easier to create some simple scene for this piece and render it with different angles. So stay tuned and wait for the next chapter. Thanks for watching.